All right, what's going on, everybody? It's Derek here, and we today are going to go through the study guide for the Azure AZ-900 exam. Okay, this is a fundamental exam from Azure, so it's pretty entry level. You don't need necessarily a ton of time to pass it, but just like with anything else, you want to make sure you do it right the first time. Okay, so, as we go through this, we're of course going to do the Pomodoro method. So we'll be taking a break every 15, 20 minutes or so to just let ourselves think and digest on what we're actually learning. All right. Uh, so let's just go ahead and get into it. This isn't necessarily going to be maybe as long as some other study guides you may see out there, in the world and on the internet, but that's okay. I'm all about efficiency. So let's see what we can do. All right. So, a little bit about me. Again, I'm Derek. Got just a few certifications, some from AWS, some from Azure. About 5 years industry experience. I write about various tech things here and just other things in general as well. So check that out if you want. And all information in this guide has been double checked by myself for accuracy and checked as well by a independent third party. Okay, so as of right now, it's January 2024 when we're actually releasing this. Everything in here is accurate and up to date. Okay, so the objectives of this guide, all right, are to introduce you to cloud computing in general and the business value it brings. We are going to use Azure as context, though. All right. Again, this is similar to like the AWS Cloud Practitioner exam, for example, except it's just Azure. And to be honest, I think this test is actually a little easier than the Cloud Practitioner exam, but that doesn't mean we're not going to be over prepared for it. Okay. We want to give you a foundational understanding of the popular Azure services that you are going to be asked about and potentially, work with if you do start, getting into a career in cloud computing. We're going to help you boost your confidence and test taking skills, right? Maybe you're like me and you're not necessarily a good test taker. That's totally fine. We'll make sure that, again, we are over prepared. So we just, we pass this test the first time by working smarter, not harder, okay? And again, I've already said this a few times, but I want you to be over prepared for your test. Doesn't mean we're going to overwhelm you, but we're not just going to do the bare minimum, okay? We're going to get after it and make sure that we are ready to go on test day, okay? And again, like I said, we want to take and pass this AZ-900 test on our first attempt. All right, so that's what we are looking to do here. What will you be tested on? It's important to know what's actually going to be on the test. You want to be able to explain the value of Azure and just the cloud in general, how it could help out, any kind of business. You want to understand the shared responsibility model. You want to understand the three domains that this particular exam is going to cover and pull questions from. You want to be familiar with the Azure global architecture, right? And that global architecture is what actually, makes up the cloud and how cloud computing works. Okay. You definitely want to understand how accounts are structured because Azure has kind of a unique way of structuring their accounts, even if it's not, the most user friendly. That's kind of how I feel, but whatever. And we want to be able to identify the appropriate Azure services for different scenarios in the domains of compute, networking, and storage primarily. But, there's also a few subdomains that we'll kind of glance over as well, all right? We're not going to really go in depth into a ton of services because for this particular test, it's just not necessary. And it's also not necessary to understand, a whole bunch of coding, non-Azure techs, right? So you don't need to be, comparing Azure to AWS or to Google Cloud or whatever. You don't necessarily need to be able to solve errors, right? It's not going to ask you what does this error mean. You're not going to need to know about specific implementation scenarios, right? So, like, companies roll out into the cloud. You don't really need to know how to architect that. You won't need to know anything DevOps related, so like load and performance testing. And then you're not going to know, or need to know rather, in depth security measures and protocols. You'll for sure want to know a high level overview of some things you can do to keep your workloads secure in Azure and in the cloud, but you don't need to go all out and really dive in and to a highly granular level, okay? All right. So, some general tips to pass the exam. Number one, and I uppercase this because I'm guilty of not doing this, okay? You want to read the question carefully, okay? Some questions are short, some are kind of long, and sometimes, I could specifically remember a few times where it will say, which of the following is not, something, but I just read like the first two sentences and look for something that is, and I just kind of select the wrong answer. So be sure to read the question to completion, read it a few times if you need to. All right. And then you want to pick out 1 to 2 keywords in a question. Okay. Is this asking you about computing? Is it asking you about, what's the most cost effective solution? You really want to kind of hone in on 1 or 2 keywords that will help you, narrow in on which answers will be most appropriate. Because a lot of times on these exams, there could be 1 or 2, potentially good solutions, but you want to find the best one. Okay. So on that note, you want to be able to rule out 1 to 2 answers. In general, there's going to be at least 1, maybe 2 answers that you just know obviously are not right. So go ahead and try to find those if you can and rule those out. Make your life easier, increase your odds of getting the right answer. And if there's anything, any answers that you do know, go ahead and, either rule those out or take them into consideration, right? So if you're getting a question that's asking you about, what's the best or most appropriate storage service, but then one of the answers is related to like, VMs. Okay, well, I know VMs are a computing resource, not a storage resource. So because I know that, I can rule that out, all right? Generally, you want to go with your first instinct, especially if you're not 100% sure about a question. Worst case scenario, though, there is an option to flag questions, and then after you get through all of your questions, it'll give you sort of a list of your flagged questions. You can go back through and review them. But on that note, make sure you use your time management wisely. Like I said, this is an intro level exam. It's not the most intensive, so you only get roughly 45 minutes. There's about 40 to 60 questions on this exam as well, so it's not a ton. But make sure you're not like flagging every other question. All right, you want to make sure that you finish the test with maybe like a few minutes to spare, so you're not like feeling rushed and stressed out. Okay. And then finally, I recommend this for pretty much any test you'll take in your life, right? I did this in college and all through school and for my certifications, and it really helps quite a bit actually, right? Don't review the day before your test, right? Because if you don't know something, uh, 24 hours before your test, you're not going to know it, right? And it's just going to, you'll potentially find like some things that turns out you're not that sure of. It'll just stress you out. You'll start trying to cram. You'll go into the test all stressed. We're not going to be perfect. You might get a perfect score, but you're still not going to know everything, right? So, just it's best to go into the test relaxed, ready to go, rejuvenated, feeling confident as opposed to feeling like stressed and nervous. Okay. All right. So, the domains that are going to be covered on this particular exam, we alluded to 3 of them. Here they are. So the first one is going to be describing cloud concepts, which is about 25 to 30% of your total score. And then you're going to need to describe Azure architecture and services. And then finally, you're going to need to describe Azure, that's AZ, management and governance. Okay. And on the practice quizzes that are available with this study guide, at the links in the description, of course, you are going to be able to, have questions that pull from all 3 of these domains, so you'll feel good walking into the exam. And on that note, I do want to say that if you choose to purchase our study guide that comes with, practice exams and this PowerPoint, you'll also notice on the PowerPoint, like right here, you'll see that in quite a few slides, I've thrown some notes down here. My face is kind of in the way, but you get the point, right? So this is a link. You just copy paste this, and it'll take you to relevant, documentation or explanations, maybe of some pictures. So be sure to check that. there's quite a few of these throughout the PowerPoint here. Okay. All right, so let's go ahead and get into it. Starting with just a general overview of cloud computing. Okay. So, cloud computing is the on demand delivery of IT resources over the internet with pay as you go pricing. All right. I really like this definition because that's basically what it is. Common resources, IT resources, are the ones that are going to be used for your compute, storage, and database and networking needs. Um, Cloud computing has two parties that make it possible. Okay, these are the two parties in the shared responsibility model, as a little sneak peek here. You've got the provider, which is the company that purchases and manages hardware. Big three, or kind of AWS, Azure, Google Cloud, but there's many others as well. And then the consumer customer, that's you and me and businesses that use the cloud. We pay the provider to use their physical resources. Okay, so that's kind of how it works, and we'll dive into how those responsibilities should be shared here in a minute. Cloud computing allows consumers to trade capital expenditures, CapEx, for operating expenditures, OpEx, so they can focus more on their business. Basically, what that means is you don't have to spend a bunch of money upfront on like hardware and servers and racking and stacking and power and all the things that come with hosting and updating and maintaining your own hardware. You can just pay as you go, or reserve capacity on, there's many different options to purchase, but again, it's much more flexible than just purchasing your own servers and hoping you got, enough, or hoping you don't get too much and just waste a bunch of money. Okay. It also increases your business speed, agility, and availability for multiple reasons that we will get into throughout the course of this guide. Okay. So, the shared responsibility model is essentially, let's start here actually. So, this is a nice visualization of it. So, essentially, what you want to remember this as is the provider. So, Microsoft and Azure in our case. They're the ones responsible for the physical components, okay? The physical hosts, the physical network, the physical data center that's hosting all these physical servers, the racking, the cooling, the powering, the up, everything related to the physical, the guarding and the security of the data centers. Okay, that's all Microsoft. It's all Microsoft, all right? But then as we start to move up the chain here, it gets a little more sort of blurry between who's responsible for what, all right? But it kind of depends on what sort of service you are employing from Microsoft, okay? And these three here, so SaaS, whatever, PaaS, and IaaS, those are kind of weird to say. We'll talk more about what those are later. But just remember this, guys. Azure and the provider are responsible for the physical hardware, right? The global infrastructure, the servers that are all over the globe, and the actual software that you use in Azure, right? So all of these services that allow you to provision resources, that's on Azure, right? You as the customer, you're responsible for pretty much everything else, right? Securing your information and data at rest and in transit, that's on you. Configuring your account's identities and access and authorization and authentication protocols, that's on you. And if you're using any third-party software, implementing it with the resources you have provisioned with Azure, that's also kind of on you, okay? So, again, moral of the story, Microsoft and their provider, they manage the physical, you're pretty much going to manage everything else, okay? So, benefits of using the cloud, there's quite a few, definitely not limited to these, but these are some of the highlights. So, agility allows you to increase the agility of your business. So, basically what that means is you can, if your business is growing rapidly, your IT infrastructure can grow with it to meet increased demand. You can employ pay as you go pricing. So, like I mentioned earlier, you can pay for resources as you need them instead of buying a whole bunch of them up front, spending, a whole bunch of money and just hoping that it's, adequate. Economy of scale. So you're going to benefit from massive economies of scale, which means that all the hardware that Azure has obviously costs a lot of money, but because there's so many people around the world using this hardware, we all sort of pitch in to pay for it together, which makes it extremely cheap. Okay. Global reach. Azure probably has the most distributed global infrastructure, at least at this point. So they have, data centers and regions all over the world. So if you have business on different continents, you can easily deploy infrastructure around the world to support that business. Security. So again, we could look back at that shared responsibility model where, when you're in the cloud, you don't have to worry about securing and dealing with all that physical hardware, okay, locking it down, whatever. Azure handles all that for you. Reliability. So, your resources are going to perform how you need them to. If they don't, you can just provision other ones. Okay. Availability. So, again, because you're able to constantly have things running in there when you need it, your resources will be in a highly available state. We'll talk more about all these later. I know they're kind of generic and vague terms, but they get thrown around a lot in the world of cloud computing. Okay. Scalability grows with demand, right? So if you, again, have a large demand all of a sudden in your business, you need more resources, you can scale up. And then if that slows down, maybe you have like a seasonal or holiday business and traffic slows down, you can scale down and get rid of some resources so you're not paying for things you're not using, okay? We don't want to do that. And then finally, elasticity means that you can quickly add or remove resources, right? In order to scale, you don't need to buy a new server, set it up, whatever. You can just very quickly provision it, say how much memory and storage, whatever, all the specs you need. Boom, there it is. Put it somewhere in the world. It's ready to go. Okay. All right. So there are 6 advantages to using Azure. 6 main advantages to using Azure that they like talking about. Again, you can trade CapEx for variable expense or OpEx, kind of the same thing, but essentially you only pay for what you use and you don't have to put a bunch of money down up front to just hope and pray that you got the right amount of resources for what you need. Okay. Azure in particular, as you may expect, integrates very well with Microsoft and or Office products. So if you're already in that sort of ecosystem, then naturally you're probably going to want to consider using Azure as your cloud provider, right? It's the same company, Microsoft doing it all, so they're going to probably have the best compatibility together, all right? Stop guessing capacity. So again, you can right size your resources over time and then reserve them in advance. If you know you're going to be using those resources, that will help you save money. We'll talk about pricing options in a while too. Encourage innovation and testing, right? So you can provision maybe smaller, cheaper, sort of side resources to test maybe, new environments, new releases of your application, maybe new like technologies. You can have completely separate environments that, again, can be as small as you need them to. You can get rid of them when you need them to. You can do whatever you need to with them, pretty much at will, okay? Again, reduce or eliminate data center costs. When your physical infrastructure is in the cloud being managed by Microsoft, all of a sudden you don't really need data centers anymore. Okay, those are expensive. We can let Microsoft deal with that. And then again, go global in minutes. So if you have demand or traffic from, maybe a country in a different part of the world you're in, you can easily deploy maybe a version of your application to multiple regions around the world to support that demand. And a lot of that can actually be done automatically too, right? Imagine having to fly to a different country and set up a data center when you could just set it up in Azure for, a very small fraction of the time and potentially a small fraction of the cost, depending on what kind of demand you got. Okay. Again, keep in mind that we will talk about cost a little later on, but some regions in Azure are going to be more expensive than other regions just because of, perhaps the cost that Azure needs to maintain resources in a specific region. Okay. So we talked about these 3 terms earlier. Let's elaborate on what they are because you'll need to know. All right. So you've got IaaS, which is infrastructure as a service. This is where we are going to deliver on-demand infrastructure resources to organizations via the cloud, such as compute, storage, networking, and virtualization. Maybe you have virtual desktops that people are using. Essentially, you are looking to rent and manage hardware. Okay. Perfect example is a VM, a virtual machine. We'll get into those quite a bit here in a short time. You then have PaaS, so this is Platform as a Service, which is where you are going to deliver and manage all the hardware and software resources to develop applications through the cloud. Okay, so essentially, it's going to require you to bring your own code that your application sort of needs to run and work and function and be delivered. And then Azure will basically just give you the hardware and the software that you need to run that application code. Right? Perfect example of this is Azure App Service, right? It abstracts out a lot of the management of the hardware and the infrastructure so that you can, again, just work on building your application, your code, making that as neat as possible. And then finally, software as a service. Basically, this is when you provide the entire application stack and you deliver the cloud-based application that customers can access and use. So you're paying to use a complete application like Office 365, or like NetSuite, or many apps you download from like the iPhone App Store. That's software as a service, right? You're installing that software onto your iPhone. Okay. Um, and that's pretty much it. All right. So IaaS is pretty straightforward. Infrastructure as a service. I sometimes get confused between PaaS and SaaS. But just know that, again, software as a service is kind of the complete application. Here you go, you're going to pay to use it. Whereas platform as a service is okay, here's everything you need to run your application, but you still need to bring your own code, build out your application, run it, update it, whatever. All right, so SaaS is going to be for sure the most hands off and user friendly. All right. All right, so now we're going to let's see what time we got. Let's actually take a quick break before we get into these cloud architecture principles, okay? Let's call it like 2 or 3 minutes, something along those lines. And then when we come back, we are going to get into some cloud architecture principles. Okay, so I'll see you back here in just a couple of minutes. All right, everybody, let's go ahead and get back into it here. All right, so we are now going to go into some cloud architecture principles. All right, and again, this is not architecting specific, deployment scenarios. This is more of how the cloud is architected in general, because it's kind of an abstract concept, right? So the Azure Global Infrastructure refers to what actually makes the cloud possible, right? It's the network of computers, servers, and all the other sort of IT related resources around the world that you can pay to use. Okay? The Azure Global Infrastructure consists of the following three components. Okay, you've got regions, which is the largest sort of slice of everything, and that's a geographical location that's comprised of data center clusters. Azure currently has 39 active regions as of December of 2023. And you could also have paired regions that sort of act as fail safes with each other, right? So, for example, you could have like US East region, you could have US West region, you could have Europe West, you could have Asia Pacific. There's all sorts of regions all over the world, right? You can go take a look at Microsoft's documentation if you really want to know all the regions, but there's a ton. Okay. And then within the regions, there are availability zones, which are composed of one or more physically separate data centers within a region that have their own power, networking, and connectivity to each other. Okay? So this is sort of where the resources actually sit. And of course, when we think about reliability and making sure that your infrastructure and your applications are always available, you definitely want to consider using different availability zones in case some kind of disaster happens, natural or otherwise. Okay. And then finally, there's edge locations, which are physical sites used to cache copies of data for faster delivery to end users. They're usually located around like crowded urban areas where there's a lot of people accessing like the internet and stuff. It's mostly used for the front door service, which kind of helps you with like content delivery and things of that nature. But again, this isn't for this test something that you are going to need to know too much, edge locations, anyways, but you definitely want to be familiar with regions and availability zones. Okay. All right, so the Azure well architected framework has a few different components, pillars, as Azure likes to call them. All right, so when you're designing applications in the cloud, Microsoft provides best practices. So, I mean, it just makes sense that we want to try to keep them in mind, right? You don't need to like stick to them, completely and strictly and never veer away from them, but it's just a really good idea to at least have them be your sort of foundation for what you're looking to do when you build out some sort of solution in Azure. Okay, so there's five pillars. Number one, operational excellence. All right, you are basically looking here to streamline your operations with just various predefined standards, comprehensive monitoring, and safe deployment practices. Okay, so big point here is try to automate everything to keep things up to defined standards and reduce human error. Security, pretty self-explanatory. Protect your confidentiality, integrity, and availability of your applications and your data, uh, and everything in between, and your resources. Okay. Reliability. This is where we are looking to design for your business requirements. So, whatever your business needs, you can count on your infrastructure to be there doing the specific job that you need it to do. Okay. If something happens, you want your recovery operations to, take effect immediately, so there's not really any downtime. But you also want to keep it simple, right? You don't want 5,000 different layers to your architecture when you could have, a couple hundred or a couple dozen really efficient layers. Right? Performance efficiency. So scaling horizontally, basically think about adding, more resources as opposed to just adding a giant monolithic sort of single resource. This just helps you to test things out in other physical boxes and servers, and also helps you to monitor your solution's health because you can sort of get a glimpse into different components of your architecture and see what's, maybe underperforming. Okay. Cost optimization. You here are looking to optimize on your usage while keeping a cost efficient mindset, right? Just think of this as don't pay for things you don't need. That's pretty much it. That's the beauty of cloud computing, right? Remember, we don't need capex. Okay. All right. So just to get a little more specific into these pillars, we won't, talk too much about them because we got a few things to go over today, but you can definitely use this as a review. So again, you want to try to perform operations as code to allow you to deploy with confidence. So you're going to limit human error by enabling automation, and that will subsequently improve your response time to events that may impact what you got going on. Foster collaboration instead of silo learning, right? So don't just have like different departments never talking to each other, trying to work on their own thing. Collaborate, be on the same page. It just helps everyone work better together, and it helps build a better product when everyone knows kind of what's going on. Establish development standards. So, what is your turnaround cycle? Do you, sort of do sprints, or do you have sort of predefined windows on when you want to get predefined things done? Be sure to document so when people quit, it's inevitable. You'll know how to pick up the slack and train new people. And then look to those that came before you. Use industry standard development methodologies like unified source control, for example, that everybody can kind of lean on. And then again, automate for efficiency. So just basically wherever you can, try to throw in automation. It just makes everything easier. Okay. Security. So plan your security readiness, right? Just be proactive. Don't wait until something happens. Right. Uh, so you want to design to protect confidentiality. So, be mindful of different tiers of data, right? Maybe you have like healthcare data that is very confidential, HR data that's very confidential. There's different tiers of data, and you may need to have different steps to protect perhaps more classified or confidential data. Designed to protect integrity. So, again, use the principle of least privilege, which means somebody accessing your resources or your data should only have enough permissions to do, their job function or what they need and nothing more. Be sure to use encryption, and then all of your backups are immutable, so people can't, mess with your backups and then restore over your current data and lead to all sorts of headaches and security risks. Uh, you want to design to protect availability. So again, make sure that if something does go wrong, that it's not going to compromise other components of your architecture. Okay, and then continuously evolve your security posture. So just be proactive, and then when things happen, learn from it, get better, continue planning, just continuously improve in all things is kind of the key takeaway there. Okay. So, reliability, again, you want to design for your business requirements. This includes monitoring KPIs, so key performance indicators, and then trigger automation when a threshold is breached. So, maybe one of your KPIs is you want maybe your application's website load time to be below, 5 seconds. But if you notice that it's on average, 7, 8 seconds or more, then maybe you need to consider deploying more resources to improve that load time. Okay. And then be mindful of dependencies that could affect other components. You don't want too much coupling going on, right? Because if something breaks, it could break other things. That's never good. Designed for resilience. So keep in mind what your mission critical components are. Things that cannot go down. Maybe you have like SLAs or agreements, other agreements that just do not allow your mission critical, your key components, your core application to go down. Okay, you want to make sure that you are designing to allow those to always be available. All right. And you want to design for recovery. So, God forbid something does happen and, there's an earthquake at a data center, whatever, anything could happen, right? Something definitely will go wrong. Cloud providers, Azure, AWS, they've all had wide, massive outages. You need to be prepared for that. So, how are you going to recover? Again, how are you going to automate it? How much do you need to back up? What kind of standby resources do you need to have? Okay. And then design for operations, right? So again, try to automate, be proactive, simulate failures so you know how your architecture and your resources are going to sort of evolve and react and repair themselves, hopefully. And then again, continuously improve. All right, it's kind of a theme here across the board. All right, performance efficiency. So, uh, you want to be able to negotiate realistic performance targets. A lot of times, perhaps shareholders or executives or somebody else who isn't very technical, they just don't understand how these things work. So you need to be able to communicate with them, realistically what we can expect from our architecture and our resources, unless maybe you're willing to pay more for more resources, right? You want to design to meet capacity requirements. So again, make sure that whatever the demand, the load on your application is, you can meet that, but you can also, potentially scale back and not be over provisioning and wasting money if you don't actually need it. Okay. Achieve and sustain performance. So pretty self-explanatory, but you routinely want to test out how things are working. Ideally, you would have repeatable tests so you can kind of compare apples to apples. Definitely want to monitor as much as you can and review those. There's a few tools you can use, especially if you have like a lot of logs for monitoring, perhaps, because you got kind of a complex architecture. And then finally, you want to improve efficiency through optimization. So, allocate dedicated cycles for performance optimization and enhance your existing architecture with new designs, maybe new tech stacks. Okay. Once again, use monitoring to track these changes and see, is it actually helping or are we just wasting time and money? Okay. All right. Finally, cost optimization pillar. Again, I think this one's pretty self-explanatory, so we're not going to go too much into it. But always keep in mind, the discipline you need to develop cost management, especially if you're at a bigger company with a lot, a large pocketbook. Don't just spend money just to spend it. It'll look good if you can get the job done without having to spend a whole bunch of unnecessary money. Okay. Uh, Design with a cost efficiency mindset. So, basically always be measuring your ROI, your return on investment. If you know you're going to be using resources, consider reserving capacity. That saves you a ton of money instead of using like pay as you go, for example. Design for usage optimization. So you definitely want to evaluate whether your chosen resources have additional features that help you meet your budgets and other targets. Okay. Design for rate optimization. So basically, as I kind of alluded to earlier, the rate you pay, generally like an hourly rate for using resources, can be more or less depending on if you make payments up front, if you use reserved capacity. So generally, how it works, and again, we'll get more into this a little later on, but the more money you pay up front, and the longer you commit to using these resources over either 1 or 3 years, the more money you're going to save, the less money you'll have to pay month to month. You could potentially even pay no money month to month if you just buy everything up front. Right? And then monitor and optimize over time. So just like kind of every other pillar, just track to see, okay, do we actually need to be spending this money? Do we need to spend more money? And perhaps what components of our architecture are actually bringing in the money, right? Are there like mission critical components that we need to maybe spend some more money on? So we just really make sure that the breadwinner here doesn't ever become unavailable or run into issues. Okay. All right, Azure account structuring. Let's go ahead and run through this. Then we'll take another quick break. So Azure account structuring, I think, is a little less user-friendly than some other cloud providers, but doesn't really matter what I think. Let's go through it. All right. So from a high level, Azure kind of groups accounts in the following manner. Okay, you've got management groups, which are here at the top. You've got subscriptions. You've got resource groups, and then you've got the individual resources. Okay. It's important to remember that permissions get inherited from the top down, is what that should say. So if you have permissions on this subscription, they're going to be inherited by both resource groups. But if you have just some permissions on this resource group, applying to the SQL server, those permissions won't necessarily also apply to this resource group over here that has a few different resources in it. Okay. So, management groups are designed to help you organize your subscription or subscriptions if you have multiple, which obviously is not uncommon, and the subsequent resources. Right? They can also be used to manage access policies and compliance. Okay. You initially, once you kind of get going in Azure, especially at an organization, you're going to have to define a root management group. But within that, you can define up to 6 levels of management groups. But you can only have, each individual subscription belong to one management group, right? So here we have an organizational management group. But then below that, we have 2 different management groups. Okay, maybe this one is our production one, and this one over here is like pre-prod, a sort of test or staging management group. And then within these, we got these different subscriptions, right? A, B, C, D. And then within those, you have different resource, workloads. They'd probably be resource groups. But these are going to be meeting some sort of solution that is using different various Azure resources. But that's kind of how, from a high-level overview, you're going to have management groups structured. Okay. Subscriptions are, again, a unit of management, billing, and scale within Azure. Okay. Subscription requirements can be based on environment type, the ownership or governance model, organizational structure, or application portfolios. So, kind of depends on your organization and what you need, but you definitely have options for how you sort of group and label out your subscriptions. Okay. So subscriptions, again, are basically just used to group together different resource groups and determine their permission boundaries. Right? So again, here we got subscriptions, and there's sort of containers for these resource groups. All right. Resource groups, or just RGs, are containers that, again, hold related resources for an Azure solution. So, maybe there's some VMs, maybe there's some storage, some other components. Resource groups can be moved to a different subscription, and then individual resources can be moved to a different resource group if you so desire. Okay, so a little bit of flexibility there. So resource groups are region specific. However, keep in mind that not all resource types are offered in all regions, and that's just a Microsoft thing. If you need to use a specific resource, you may have to use it in a different region if the one you're primarily in doesn't offer it. Okay, not the end of the world. There's ways around it, but just be aware. All right, and then at the most granular level here, we have the actual resources, which are the compute, networking, big data, analytics, storage, whatever. Basically, any IT resources that are actually going to comprise. I don't know why I can't read that word, that comprise your applications, right? So basically the resources are what actually do the work, okay? And you keep those resources in a resource group. Typically your resources are managed by Azure Resource Manager. Definitely keep that one in mind. You will definitely see something on the test about Azure Resource Manager. It's just kind of a one-stop shop to help manage all of your resources in one place, okay? There's currently over 200 services that you can create resources from, so there's endless combinations. Of course, this is just a snippet from the Azure portal of a few common popular services, but you can see here that if you were to go to this all resources, then you would most certainly be overwhelmed with the amounts of resources you could get your hands on. All right, so Azure Compute. So this is going to start the first of the 4 beefier sections. So let's go ahead and take a break here, and then when we come back, we'll start diving into some compute. All right, so let's go ahead and take that break for like 3-4 minutes, something like that, and then we will see you back here in a few minutes. All right, let's get going back here again. Okay, so we're going to pick it up here with Azure Compute. All right. So compute is basically the brains of everything, right? It's the tier of service that's used to process workloads, handle application logic, evaluate rules, react to condition. Basically anything that does anything, you're going to need compute, right? We're working with computers, so it makes sense you need compute. The main services in this domain are going to be Azure VMs, functions, app service, and container instances. Okay, so again, all these services known from a high level. You don't need to be an expert in them yet. Okay, so virtual machines, we're pretty much always just going to refer to them as VMs. It's easier, it's faster, it's what Microsoft does, so that's what we're going to do. So VMs allow you to provision Linux and Windows VMs with the sort of configurations of your choice. A VM is basically an emulation of a physical computer using software, so it's like using a computer without actually having, that computer in front of you. Multiple VMs can run on the same physical server, which, is what allows us to share the costs of that server with other customers. VMs are highly customizable for just about any use case that you could potentially think of or need them for. And then Azure Resource Manager uses templates for creating VMs, which enables automation. You can configure components such as, your RAM, your processor cores, how much network bandwidth you want to give it, what type of OS it's going to use. This all depends on, your company's use case, but just know that a lot of it can indeed be automated. All right. So VM types. There are many types of VM classes you can use depending on the use case. Again, you don't necessarily have to memorize, you especially don't have to memorize like the letters here, but it's just nice to know what type, what your VMs can actually be used for. So you've got your general purpose, which are just kind of a balance of compute, memory, and networking. These are probably going to be the cheapest, maybe the most efficient, unless you have a specific use case. Compute optimized, those are best when you need high processing power. Memory optimized are used for workloads that are going to process large data sets in memory. Okay, so that's a good indicator there of what memory optimized for. It works in memory. GPU optimized is for graphics intensive workloads, and then storage optimized, of course, is for high read and write access to large data sets on local storage, right? Local meaning on your VM. Okay? VM pricing models, so you'll definitely want to know these. So the default is pay as you go, which means you only pay for what you use. It's paid on a monthly basis. You can add or reduce, what you got going on at will. Right? Reserve VMs, so if you know you're going to be using VMs, they're going to have a predictable usage, maybe throughout like the work week, or they're just mission critical, right? You can reserve them for a period of 1 or 3 years of usage. Okay, if you reserve them for 3, you're going to have a larger amount of savings than reserving them for just 1. Okay. You can actually apply this reservation discount to another VM in the same size, group, and region if you need. You can pay upfront, partial upfront, or no upfront. Okay? If you pay more money upfront, then you're going to save more money, right? So even though it is going to be obviously more expensive in the short term to perhaps pay for VM usage, for 3 full years. Over the course of 3 years, you're going to save a substantial amount of money, right? So if you know you're going to be using these VMs, you might as well reserve it, just pay for it, and then get it over with, and then move on with your life. Okay. You could also do partial upfront, which is going to lower your monthly payment that you pay for the monthly for your VMs, or you could do no upfront, which is going to leave you with the highest monthly payment. Okay. You can also refund a reservation up to 50 grand in a 12-month rolling window if you no longer need it. Okay. And then spot VMs, this is a nice benefit of cloud computing, but this is essentially unused compute capacity you can buy from Azure with up to 90% savings when you compare them to, even on-demand and pay-as-you-go pricing. All right, it's designed for workloads that have flexible start and end times because Azure can actually take back that spot computing capacity at any time. You'll get like a warning, a brief warning, but again, you should not be running mission critical workloads on spot VMs. These are more for like, maybe functions or like batch processing, things that you don't mind having interrupted at any given point, okay? All right, so VM scale and availability sets. Skill sets allow you to create and manage a group of load balanced VMs, providing the following benefits. It's pretty, let's chill out there. It's easy to create and manage multiple VMs, as they're all kind of grouped together. It gives you high availability and resiliency by distributing workloads across, the different VMs in your set. And then it allows your applications to scale automatically as resource demand changes, which you may guess from the name of skill sets. And then, of course, they work at large scale because you could scale basically as much as you need to. You can use scale sets with Azure Load Balancer or Azure Application Gateway. Right? Now, availability sets, on the other hand, are logical groupings of VMs in the same data center that allow Azure to understand how your app is built so it can provide redundancy and availability. Okay? It's going to offer improved latency compared to using different availability zones. But, using different availability zones gives you the highest level of reliability because if, again, something happens to that availability zone and you're only in that one availability zone, then your entire application could potentially be offline, which could definitely be a problem. All right. So fault and update domains. All right. I've definitely been asked about these before, so we're just going to briefly go through what they are so we kind of are all on the same page here. All right. So fault domains define the group of VMs that share a common power source and network switch. All right. So for example, a fault domain, this would be like a rack of servers, okay, and all these 5 servers here. Okay, we got 3 racks, 3 fault domains. All these servers are sort of connected by the same power source that, this entire rack is sort of using and relying on, okay? So everything in this fault domain either works together or fails together, all right? Update domains are a little more granular. They define the groups of VMs and underlying physical hardware that can be rebooted at the same time, which basically means that you'll always have at least some VMs available on or within a fault domain, rather within your rack, within the Azure Data Center. You'll always have something available to run your application, right? So in this one, for example, is fault domain 1. We've got 5 boxes, right? This box is update domain 1. This box is update domain 2. So what that means is, okay, maybe we take down, these 2 to, and by we, I mean Azure. Maybe they take them down to patch the hardware or to, clean it up, whatever they're doing. These other 3 boxes are still available, right? Same thing over here, and then of course same thing over here. All right, you're always going to have these available. Well, assuming they're not part of another update domain, but the point is that an update domain allows you to have some remaining availability within this fault domain, whereas if one fault domain fails, every sort of VM and box and rack in here is going to fail together. Okay. All right, VMs and containers. So VMs utilize software and an operating system, that's an OS, to replicate using an actual server. Containers are going to have everything that an application needs to run on a server except the OS, which is by design, right? They're designed to be flexible and basically run anywhere over any type of OS and kernel. Okay, so you have within this container umbrella in Azure, you have container instances, which let you run workloads with hypervisor isolation. So probably don't need to know that, but just know that, containers don't necessarily share a kernel. They're not dogs, they're computers, a kernel. Container apps, so this allows you to build and deploy modern apps using serverless containers. Basically means that you don't have to manage as much of the containers yourself. They're just out there running and being, maintained as Azure. This could, potentially be that, PaaS we were looking at earlier. Okay? And then Azure Kubernetes service is slightly more hands-on container management and orchestration service that uses Kubernetes, as you might guess. That's pretty much all you need to know there. You definitely don't need to get in depth with containers and Kubernetes. Just kind of know from a high level that containers allow you to run an application on a server and it has everything it needs to run except for the OS. And then Kubernetes allows you to sort of organize and manage and orchestrate, as they say, those different sort of containers. Okay? All right, so serverless. We're going to take a brief detour and just talk about what this word means because you're going to see it a lot. And it's one of the huge selling points of cloud computing, okay? So serverless doesn't mean there's no servers. Instead, it means that there's an absence of a physical dedicated server, right? So it's not like if you had your own on-premise data center, all those servers, those are your physical dedicated servers. In the cloud, you don't really have that, okay? You just say what you need, and then Azure just provisions you a server, okay? If that server breaks, Azure just provisions you another server. You're not tied to a physical dedicated server, okay? Azure Functions are all serverless. Azure App Service is also serverless in that you can have, that entire application environment not dependent on any sort of dedicated specific hardware. And of course, containers and their associated services like Kubernetes are designed to be serverless as well. Okay, so that's kind of what serviceless is. Just know that it means that you don't need physical dedicated servers. You can just kind of say what you need from a computing or storage or whatever standpoint, and then you'll just have it somewhere out there in an Azure data center. All right. So Azure Storage. Storage is a little different from database in that it's a little more flexible in how you can actually store and format your data. So a database typically requires data to be formatted in a certain way. Relational databases will use like columns and rows, but even NoSQL databases kind of look for key value pairs. But with storage, you could just kind of say, hey Azure, I just want to store this media file. I just want to store this text file. I just want to store whatever. And Azure's like, okay, cool. So within this, we got 5 main storage types. So we've got blobs, otherwise known as containers, which is one of the things that Azure does that I think is really annoying because that's not really a container. We just talked about a container, but whatever. You've got file, queue, table, and disk storage. Okay. So blob's probably going to be the most popular, most common. It's got 3 tier types. Right. And of course, some other different storages also have tier types, but blob again is the most common. So you've got hot, which means that data is frequently accessed. It's the most expensive because it's constantly being read and perhaps modified. You've got cool, which is infrequently accessed data. It's cheaper than hot, but it's got a higher cost for reads and writes because, again, it's not necessarily designed to be accessed as frequently. Your data must remain cool for at least 30 days. After that, you can do what you will with it. Right? You can even automate that. Maybe you want to move it to hot. You can do that. All right. And then archive is for rarely accessed data. It's by far the cheapest. 5 times cheaper than cool, in fact, but the data must be in this archive for at least 180 days, so you probably won't use this for a lot, but it's useful for things like maybe important documents for auditing or taxes or whatever. Okay. All right. So storage accounts. We are going to briefly talk about these, and then we'll get more into actual storage types, but basically a storage account contains all of your storage resources and their configurations. And that's pretty much it. This is just a screenshot of the Azure portal here when you're making a storage account, right? So what subscription do you want this storage account to be in? What resource group do you want this storage account to be in, right? And then within here, you could, of course, have the specific details of this particular storage account, right? The name, the region, what sort of performance, what sort of redundancy. Okay. So you have a few options for redundancy, which redundancy basically ensures that your storage account meets its availability and durability targets even in the face of failures. Okay. This is done by storing multiple copies of your data in physically different locations. You've got 6 options here. Okay, and these are listed from least to most expensive and least to most redundant. Okay. So locally redundant storage is where the data is replicated across racks in the same data center. Sure, it works, but if something happens to that data center or even just that rack, then you're done for. Zone redundant storage, so it's going to be replicated across 3 availability zones in a single region. Geo redundant storage is where your data is replicated across 2 different regions. Read access geo redundant storage, GRS, is the same up here, except you can, of course, read a second region's data immediately instead of there being sort of a delay. Geozone redundant storage is sort of a combination, of zone and geo redundant storage, as you might guess from the name. So it kind of combines the benefits of both of those into a more redundant but also more expensive storage option. And then this, as you might guess, is pretty similar to the geo zone redundant storage, except it gives you that immediate read access if you so desire. Okay. Excuse me. All right, Azure Blob Storage. So this is a massively scalable and secure object storage for cloud-native workloads, archives, data lakes, high-performance computing, and machine learning. So as you can see, it's very flexible in what you can actually store in here. So some reasons you would use blob storage are perhaps you need a very cheap storage source for unorganized data, or maybe you just need a place to put your files, videos, whatever. You can configure lifecycle rules to automatically move your data between the hot, cool, and the archive tiers. It does support these 4 different redundancy options that we just sort of talked about earlier. And of course, the price depends on the amount of gigabytes that you are storing, your data, and what tier, right? Hot, cool, archive. What sort of redundancy, what sort of operations you're doing on your data. Are you transferring data out? Generally, that costs something. Generally, transferring data in is free because they want your data, they want to hold on to it and have you pay them to store it. But there's all sorts of factors that you can play around with to affect the price of your blob storage. Okay. File storage is a simple, secure, and serverless enterprise grade cloud file share. It uses a standard SMB and NFS protocol, and it can be mounted on Windows, Linux, and Mac OS instances. Okay. It works with a service called Azure File Sync to offer the capability for a hybrid file server. So maybe you have some of your, files on prem, maybe you have some on Azure. This allows you to kind of keep them in sync, working together. It supports these redundancy options. The cost depends on, again, pretty much on the same factors, the same variables. It's typically more expensive than like a blob storage due to its file share capabilities. It's pretty user friendly and very commonly used. Okay. Azure Queue Storage is designed to asynchronously pass messages between applications via HTTP and HTTPS. So asynchronously basically means that your messages aren't dependent on each other to either be read, consumed, or sent. They can kind of just go whenever they're ready. Your queue storage, of course, must be in a storage account, and it's consistent of queues and messages. So queues contain a set of messages. It can even be millions of messages if you have a lot going on. It may be an enterprise level operation. And your messages can be up to 64 kilobytes in size. Okay, it supports these redundancy options. And your pricing is going to be based on the number of transactions and amount of data stored, typically cost friendly since you can delete messages right after they get consumed. You can also expire these messages after a given amount of time, right? X amount of time if they haven't been consumed, just so you're not, paying to store them. Okay. So helpful storage there. That's typically used to allow applications and services to talk, to each other and sort of trigger events or notifications or operations. Okay. Azure Table Storage is another thing that I think is kind of annoying that Azure does, but whatever. It's actually a NoSQL data store that uses semi-structured data sets. Uh, and I know it says storage, but if you go look for it, it's actually listed in databases in Azure, which again is even more confusing, which is cool. So, typically when you think of tables, you think of like SQL, but that's not the case here, but whatever. But in this case, these tables are a collection of entities, so they're schemaless. And an entity is basically a set of properties that's similar to like a database row, okay? A property is just a name value pair, and then your costs are determined by the data stored and the operations you are doing on your data. And then, of course, it supports these different redundancy options. Okay, so here you can see you have a storage account. Maybe this storage account, belongs to Sally, and then in here she's got a couple tables. She's got a customer table, and then a wine photos table. And then maybe within this table, we have name equals, I don't know, maybe she's got a customer named John. His email is john@gmail. And then maybe it has this, customer named, Tina, Tina@gmail. But then you could also have this table of wine photos that has different entities, again, as they are called, where perhaps you've got a photo ID and then maybe the date that the photo was actually taken. Okay, so it's a pretty flexible storage service. Excuse me. And, you definitely have some options on what type of data you can define in here using these name value pairs. Okay. All right, finally, we got Azure Disk Storage. You're probably not going to use this too much because it's more for like legacy and archiving data, but essentially it's block storage, uses disks attached to VMs. It's automatically created when you make a VM. It really only supports locally redundant storage. It's designed for block storage, again, directly on that VM. It's best used when you need high throughput and low latency, as opposed to like data durability. And the pricing is going to depend on the disk type. You got a few different options there, and how much gigabytes you have provisioned and what kind of data transfer you got going on. It's often more expensive than other storage because of how well it can perform because it is directly on that VM. So consider that when you're looking at disk storage, right? If you need something that's quick, uh, consider disk storage. But again, it's not very durable. It's not a good long-term solution. Okay. And again, it's also not very common because, most people don't necessarily want their storage to be temporary unless maybe you're doing like, again, like batch processing or maybe logging some jobs or logging some kind of monitoring processes or something along those lines. Okay. Let's just real quick go over some miscellaneous storage services that you'll at least want to know what they are. Okay? Because they're designed to work with these storage services that we just covered in this section. All right. You've got Azure Backup, which provides backup and recovery solutions for Azure services, ensuring data protection and disaster recovery. You've got Azure Site Recovery, which offers disaster recovery capabilities by enabling replication and failover of VMs and workloads. AZ Copy is a command line tool that moves your data in and out of Azure storage. Azure File Sync, kind of talked about this one a little bit earlier, but it allows you to, centralize your file shares in Azure files. Basically allows you to kind of have a hybrid on-prem cloud file server. Azure Data Lake Storage is a scalable, secure data lake for high-performance analytics. And then Storage Explorer allows you to manage your cloud storage accounts and multiple subscriptions across all regions. Okay. All right, we're getting close. We got database, network, and then just a few things that we're going to get into after that will also be on your test. But For now, let's go ahead and take another, few minutes break here, and we will come back and get right back into databases. Okay, so we'll see you in a few. let's go ahead and get back into it. We are just moving right along here. All right, so databases. Databases store semi-structured and structured data. Okay. Uh, this is going to be the primary difference between a database and, say, a storage service. As the storage is a lot more flexible in the data structure it accepts. There's two main types of databases. Right? There's relational, which are rows and columns, like Excel spreadsheets. Pretty much that's exactly what a relational database is going to look like. And then you have non-relational databases, which are similar, but they, mostly, well, most of the time they work using key value pairs. And then generally, databases are used to structure data, so it's easier to access and query. Sorry about this, guys. Give me a second here. So if we think about key value pairs, this isn't the most obvious concept to everyone, so let's just brush over what it is, because it's important to know this with NoSQL databases. Okay? So a key is going to be referencing an attribute of an object and a value that describes it. So for example, you have keys like name, age, job, city, email, and then values will be like a name of Bob, age of 25, etc., etc. Okay. And sorry, Jesus, guys, hold on. Relational database services, so they are going to support the most common SQL-based databases such as MySQL, MariaDB, PostgreSQL, Oracle, etc., etc. Of course, you would expect Microsoft SQL Server as well. So consider using a relational database when you have data that needs to be structured in a specific way. Okay? Again, like I said, relational DBs, very, very, very similar to an Excel spreadsheet. Non-relational database services, so you've got Cosmos database. This is kind of the primary offering from Azure. It's supported, or it supports rather, MongoDB, Apache Cassandra, PostgreSQL, which is interesting because, again, NoSQL doesn't necessarily mean you can't use an SQL database. It just means that you use, key value pairs more than you use that strict table structure. All right, so that's kind of interesting. Again, also kind of confusing, but luckily for us, for this exam, we don't really need to know these fine details. Just know that, again, Cosmos DB is the primary NoSQL database from Azure. Okay, and then you've got these two, MongoDB Atlas, and then Cosmos DB for MongoDB. It's just a document database storage option. Meant to support MongoDB and other document database storages in an Azure environment. Okay. A couple other database services you may just again need to know what they are, what they do. You've got Azure Cache for Redis. This is designed to provide your applications with high throughput, low latency data caching. So just from a high level overview, when you cache data, that means you just store it very close to the user that's going to be accessing it, so they just get it faster. So you have Azure Managed Instance for Apache Cassandra. That's a mouthful. Name kind of describes it, but it's basically designed to support processing of big database workloads. And then Database Migration Service. This is what you would need if you were going to move an on-premise database to Azure, or if you're going to support Microsoft SQL Server, or any of these other types of database migrations. Okay. All right, pretty easy. Databases, again, you don't have to know too much about them. You just got to know kind of what they are, what they do. All right, so let's get into some networking. This may be the most confusing section, but we'll try to break it down. So VNets are going to be the key component of Azure Networking. Subnets are going to help segregate your VNets into different groups so you can easily sort of separate your different resources. You can connect two different VNets together with VNet peering. For other options, you can use Azure VPN or ExpressRoute with a point-to-site or site-to-site connection. We'll get into that here in a second. And then some resources like storage containers can't actually be put into a VNet. All right, in that case, you'd need a endpoint, usually a private endpoint. We'll also get into that shortly, okay? So this Right here, we're actually sort of going to jump around and reference it a few times as we go through this section. It'll make more sense once we sort of break down the different components of it. But you can, of course, use this as a reference for a general overview of how you would sort of uh, set up the networking of an Azure solution. Okay, so virtual network, aka VNet, and subnets. You've got VNets, which are the larger portion of this. They allow you to logically separate your resources into groups and away from other Azure customers that will potentially be using the same hardware. So upon VNet creation, you need to specify an IP address range. That basically means, when your resources are in this VNet, what's the range of IP addresses they can hold. Okay. You need to specify which subnets are going to be in it, the name of the VNet, the subscription it belongs to, and which region it's going to be in. Okay. Again, IP address range tells Azure what range this VNet's resources can use. The subnets are smaller partitions within your VNet that also utilize IP address ranges. They need to have a smaller IP range than your VPC. Okay? Subnets can be either public or private depending on what type of resources are going to be living in them. And then, of course, your Azure region is going to dictate where your resources will, physically be located and operating. Okay? So if we come back here, we've got this VNet here. Okay? And then we have this subnet. So within this VNet, this is our IP address range, 10.1.0.0/16. And then this subnet's range is 10.1.1.0/24, which does fall in with this sort of larger IP address space. Okay? And then within the subnet, you've got a private or a virtual machine rather with a private IP address that has this specific IP address. Okay? So that's a VNet, and that's a subnet. Okay. All right. So Azure DNS, a domain name system, is basically what allows you to translate a name into an IP address or vice versa, so resources can communicate. Right. So when you go to like Google.com, it actually switches that to an IP address that reaches a server that does whatever it needs to do. DNS is actually automatically included if all your resources are in the same VNet, which is nice. Private zones, though, are required when you want to resolve names between VNets. So if you've got more than one, which is not uncommon, you're going to need some private zones. And you can also use on-site DNS services when on-prem resources are involved to kind of connect everything and have that hybrid environment. Okay. So if you want to connect to other VNets, because it's rare that all your resources will be in a single VNet. The most straightforward way to do this is to use VNet pairing, where you have a one-to-one relationship where your VNets can be either in the same or a different region. The connection goes over Microsoft's backbone network instead of traversing the internet, which is faster and, of course, more secure because it stays off the public internet. To connect to an on-prem network, you need two things. Well, you need one of two things, I should say. You need either a Azure VPN, so a virtual private network, which, again, traverses the public internet to make the connection. It's going to encrypt your traffic that goes over the VPN. It requires a VPN gateway in the VNet, okay, on the Azure side, and then a local network gateway in your on-prem data center. Okay, so those are kind of the two points, if you will, that allow your VPN to tunnel back and forth. You also have ExpressRoute, which is much more expensive and faster because it's basically a physical connection that bypasses the internet. Think about like plugging an Ethernet cord into your computer, right? It's super fast. That's basically what it is, right? You route cables from your data center to Azure's network of data centers, just different regions, availability zones, whatever. And we talked about this earlier, right? So PTS versus STS, okay? So you've got point to site versus site to site. So point to site connects a single device, like your phone, to a VNet, so maybe like an end user. And then site to site connects multiple devices, so maybe like an entire office building to your VNet, okay? So depending on the scale of how you need to connect to your VNet, these are the kind of the options you have. All right, you can use route or policy-based routing, and again, you don't need to know too much about these, but just know that route based routing is recommended for most use cases. Okay? All right, so private endpoints. Like I said earlier, some services, resources can't be put directly into a VNet, so you're going to have to connect to those with a private endpoint. So private IP addresses in a VNet are connected to an Azure resource outside the VNet via the private link service. You can also use public endpoints, but of course, when you do this, you're exposing that to the internet, which can potentially be a security risk. So in this case, say we have a VM that we want to connect to this Signal R Azure service. We can set up this private endpoint here within our VNet to send out that connection request to Signal R, and then it can then return the response to our VM, all by bypassing the public internet. Okay. All right, so let's just go back here. Now that we have an idea of what this looks like, let's just sum this up, okay? So we have the public internet out here. We've got this giant box that is our Azure sort of conglomeration of resources. This is our Azure cloud. We've got our VNet, which has a subnet with their defined IP address ranges. We've got a virtual machine with a private IP address that is using a service endpoint, okay, likely a private endpoint because it only has a private IP address, to come over here to this store. It looks like a table storage to connect to that, okay, using, again, this private IP address from the VM, okay. This is within an Azure Storage account, and this storage account and this table storage is allowing this VNet's subnet to access and communicate with it, but it's also allowing the on-premise IP addresses to communicate to it as well, right? So we have kind of a hybrid setup here because you have some resources on-prem, some resources in the cloud, okay? And in this case, we have an express route connection, right? So that direct physical connection bypassing the internet that is connecting our on-prem resource to our Azure storage that is within the Azure cloud, okay? So hopefully that makes sense. Again, this is a very simple architecture that, just kind of hopefully gives you the idea of how a VNet, a subnet would work, how you would need to have endpoints configured to talk to different services and sort of weave everything together and make it into a comprehensive solution. Okay? All right, so let's go ahead and take a quick break, and then when we come back, we'll get into Azure Security, Identity, and Access. Okay, so we'll take a quick break, and we'll see you here in a few minutes. Okay? All right, let's get back to it here. So we're getting pretty close. We've got the main four sections there. So let's just see what we can get done here. All right. So what we want to remember for this section is that an effectively secured application has security at multiple layers. Okay, so it's not just like just encrypting your data, it's a lot more than that. Okay, so you can think about security at 7 general layers, right? So your data itself, what kind of access are you allowing to this data? Again, are you encrypting it at rest and in transit? Your application, right? So do your apps stay updated, or do they have vulnerabilities that need to be patched? Make sure you're patching those, right? Regular updates. Your compute resources, so controlling, what users, what applications, what resources can access your VMs. Your network, of course, just control access to and from, the network that's containing your resources. So perimeter security, this just kind of allows you to stop wide-scale attacks that could have sort of a wide blast radius before they even happen, like DDoS attacks. Identity and access, so again, control access to your infrastructure and change management. And then the physical security, so limiting access to a data center to only authorized personnel. This is, more on Azure's end, of course, unless you have, like a hybrid or on-prem environment. Okay. So, encryption allows your data to stay confidential at all stages of its life cycle. There's two primary modes of encryption. You've got in transit, which is SSL and TLS. You'll commonly see this as like, HTTPS websites instead of HTTP. And then at rest, so like your database instances, your blob storage, your backups, you can encrypt pretty much everything you need to encrypt at rest, okay? One of the most popular and secure types of encryption is AES-256, but just so you get an idea of how encryption kind of acts and works, below is an output from using this different type of encryption, which is actually considered a little less secure than AES 256-bit. So if I put in the input of hello and then encrypt it using SHA 256, this is what I get. So, I mean, if you were to show me this, there's no way I would know that it says hello. So that's kind of how encryption works. It just makes plain text basically unreadable, all right, which is what you want. And then data is encrypted and decrypted with encrypt and decrypt keys. All right. So authentication, authorization, access control. Three sort of concepts you want to be familiar with. So authentication is verifying that a user or login is who they say they are. Some of these, authorization methods that are going to sort of rely on authentication being built in are things like SSO, MFA, and passwordless, right? Authorization is applying policies that define what a user can and can't do, like RBAC, template policies, etc. Hold on guys, this should actually say authentication. These words are very similar, aren't they? Authentication methods, there we go. Let's get back in here. So yeah, authorization, so things like RBAC, which we're going to get into here in a second, template policies, etc. And then access control is how your data and resources can be accessed. So can they only be accessed from a specific subnet via HTTPS, whatever. So quick recap: authentication, verify someone is who this says they are. Authorization, say what they can and can't do. And then access control, how can they do that? Okay. So Microsoft Entra ID, formerly known as Azure AD or Active Directory, you might have heard of at some point. It gives your organization the following features, a lot. Here they are. We don't have to go through them, but that's it. It's kind of the go-to service for directory-related things when we're talking Azure, we're talking Windows. Azure RBAC is a little different in that it stands for role-based access control, by the way. It lets you manage who has access to your Azure resources, what they can do with them, and then what areas they can actually access once they get into your resources. Okay. The most common roles you'll see include a contributor role, which includes full access to all resources, but they can't assign RBAC roles. Okay. owner is the same as above, but they can access or assign RBAC roles rather. Reader is, as you might expect, read-only access to resources. RBAC admin manages RBAC role assignment to resources via RBAC only. Okay, like you can't use Azure Policy, for example. It's kind of a different domain and, again, layer of security than RBAC is. And then user access admin is basically going to be someone who can manage user access to your Azure resources and say, what they can and cannot access. Okay. So there's three key components to a role assignment when we talk about RBAC. There's the security principal, which is just an object that represents a user, a group, a service principal, a managed identity, something that is requesting access to your Azure resources. Okay. After that, you have a role definition, which are a collection of permissions. It's usually just called a role. Sometimes you'll see role definition. But essentially, it kind of tells you what you can and can't do. Okay. So for example, here, if we look at the definition of this particular contributor, you can see that actions, they can do pretty much anything. Not actions, they can't do a few things in regards to deleting and writing and giving elevated access. So remember that denies are going to override allows if there's ever conflicts. Okay. And then there's miscellaneous actions you can also assign as well if you so desire. But yeah, that's a very simple role definition of a contributor of what they'd be able to do. Okay, and finally, scope is a set of resources that the access applies to. Right, so does it apply at the subscription level? And then remember again, that's going to trickle down to these resource groups and these resources, or do you only want to apply it maybe to like a specific resource group? Okay, you can get pretty granular with scope that you apply to your access policies and your role definitions. Okay. All right, and you can even see here that's kind of where you would specify it in your role definition, right? All right, so how RBAC determines if a user has access to a resource. This is kind of a long section, so we'll just try to simplify it as much as we can here. But essentially, what happens is a user or like a service principal, right? Maybe another Azure service working with other services that you have. They acquire a token that's going to be used for Azure Resource Manager, okay? The token is going to include the user's group memberships. And if they have any like transitive group memberships, those will be included as well. Okay. Once they have this token, after they're, requesting access, the user is then going to have a REST API call made on their behalf to Azure Resource Manager with that token attached. The Azure Resource Manager is going to retrieve all the role assignments and deny assignments that apply to the resource upon which the action is being taken. If a deny assignment applies, access is blocked, otherwise evaluation continues. So remember, deny overrides allow. Azure Resource Manager narrows the role assignments that apply to this user or their group and determines what roles the user actually has for this specific resource. Okay, Azure Resource Manager determines if the action in the API call is included in the roles the user has for this resource. Okay. If the roles include actions that have a wildcard, okay, so right here, actions, this is a wildcard, this asterisk, then the effective permissions are computed by subtracting the not actions from the allowed actions. So basically, this contributor, you subtract these out of the equation, and because there's an asterisk here, this contributor can do basically everything else except for, these specific actions, okay? And then similarly, the same subtraction is done for any data actions. So if you had not data actions here, those would also be excluded from this, asterisk actions. Okay. All right. So if the user doesn't have a role with the action at the requested scope, okay, so if maybe the scope is over here, but they're trying to access resources over here, then that access is going to be denied. Otherwise, the remaining conditions are going to be evaluated. Maybe there's a conditional, did they use MFA that's required? But otherwise, if the role assignment includes conditions, they're going to evaluate. Otherwise, access is allowed. And then finally, if everything is met, access allowed. Otherwise, access is denied. So it seems like quite a bit. This, of course, happens in just a few seconds, this whole evaluation process, but it's definitely nice to know at least what's going on under the hood. But again, a lot of this you probably won't need for this specific test, but we want to, again, be over-prepared. All right. All right, so moving on here. External identities. I think we're almost done. We are. Nice. So when you use Entra ID, formerly known as Microsoft Active Directory, you can authenticate credentials that come from outside your organization, and they can be from maybe another organization or an open ID provider like Google or Facebook. So another organization is typically B2B, so business to business, and then OpenID is business to consumer or customer. I always forget which one it is. But basically, this provider like Google or Facebook, which is obviously a trusted provider, they manage this actual identity, and all you have to do is control what sort of access this identity is going to have to your apps, right? So it takes out that whole authentication process out of the equation. You don't even have to do or deal with that. It's kind of already done for you, okay? So, I'm a visual person. I like pictures. Here's a picture. If we're talking B2B, right? So another organization, that vendor, again, maybe Facebook, maybe Google, maybe just whoever else you're working with, another corporation, whatever. Maybe they have their own, domain email address, password, whatever they're working with. They receive an invite to get access to your resources in your tenant, your architecture, your cloud, whatever. They're going to log in and follow this whole process. They're just going to log in using, their Gmail or, whatever it is. Okay. So Azure AD B2C, on the other hand, is slightly different in that, again, you are specifically looking for a sort of single user or single organization as opposed to like a global sort of spectrum of people that could belong to a giant organization or just anybody from Gmail. Okay, it's a little more specific. And then a user is going to basically sign up themselves to access your applications or your resources, whatever. But the same thing's going to apply, right? They're going to acquire that token. We're going to go through these steps. Okay? So that's kind of visually what's going on. Again, don't really try to get your head wrapped up too much around it because you definitely won't know this level of detail. We just want you to be slightly over prepared. Okay? All right. Security best practices. So the concept of zero trust consists of three principles. You want to verify explicitly, okay, which means you're going to always authenticate and authorize based on all available data points. So use whatever you can to make sure that somebody is a legitimate person. You're going to use least privilege access, so give the users and or services just enough access to accomplish the tasks they need to accomplish. Assume breach, so something happens, minimize the blast radius and segment access, right? Or if something fishy's going on, just again be proactive with monitoring and logging that threat detection. Right? Do something about it. Don't wait until it's like a full-blown friggin' attack and your entire infrastructure is bugged out. Be proactive. Assume something's going on if something seems off. Okay. The defense in depth model can be related back to key concepts of the section we just kind of went up to, and like I said earlier, there's some details specifically for this at the links and notes. Microsoft Defender for Cloud is kind of nice because it integrates best practices from Microsoft into your applications. And, Microsoft has more experience than you and I will ever have, so let's follow their recommendations, might as well, all right? Network security groups, real quick, so they can be applied at the subnet or like the NIC level, so sort of the specific VM or instance level. So this is like network interface. So a subnet applies to all resources within it, and a NIC, network interface, applies to a specific piece of hardware in a specific subnet. Okay. All right. Azure Management and Governance. Let's see, what do we have here? Okay, we're almost done. Let's go ahead and go through this section, and then we'll take our break. Okay? All right, so management and governance refers to what policies your organization employs to keep resources and access to those resources up to defined and evolving standards. Okay? This allows you to minimize risk and have overall greater control on how your applications and resources operate. Okay? The primary way to interact with and manage your resources are the Azure portal, the Azure CLI, Cloud Shell, and PowerShell, and of course ARM templates, so Azure Resource Manager templates. The primary management and governance-based services are Azure Policy, Microsoft Purview, and Azure Arc. The last two are slightly newer. Azure Policy, though, is very common, very popular, so you'll for sure be asked about policy, so we're going to get into that. All right. So the best way, the most user-friendly way, rather, to interact with Azure is to use the portal. And it's just a web interface, right? You go to portal.azure.com, and it's a user-friendly visual browser-based tool that just allows you to sort of browse and manage and add and remove and whatever you need to do with your Azure resources. It's a good place to start, but in reality, you're going to want to use other methods to be more efficient, especially on like larger and more complex architectures. Okay. Um, so this is just a screenshot of what the sort of home dashboard of your Azure portal is going to look like. All right. So Azure CLI, Cloud Shell, PowerShell, they're all pretty similar, so we just grouped them in here. They're more advanced tools for developers and more technical end users. It's a highly efficient way to manage resources once you sort of figure out the syntax. So this is kind of what they look like. So this is a CLI. It's in a command prompt. Just, you could run a command like, what's the version of my Azure CLI? There it is. Boom, boom, whatever. And then this is a PowerShell session within the Azure Cloud Shell. So it's kind of grouped up all in one, but this is, you could see here, it's in the Azure portal, so it's a browser-based shell. All right, but again, don't worry about these too much. Just know what they are, but you don't need to know how to use them, what the syntax is. Just kind of know what they are from a very high level, okay? ARM templates. So these are definitely interesting. One of your best friends when it comes to enabling and supporting automation. So ARM templates let you define your infrastructure as code, IAC, you'll see that quite a bit, so that you can better manage deployment and modifications to your resource stacks, right? Keep it automated, reduce human error. Super important. ARM templates give you the ability to automatically create, edit, and delete your resources, and as you can see here, this is just a demo, a sample of what an ARM template may look like. Or a section of it rather. You can see it kind of cuts off, keeps going. These can potentially be quite large depending on what you got going on, but of course you don't necessarily want to have all of your resources and your entire architecture in one template. You want to sort of segment things out, okay? But you can see here we've got like some different parameters to sort of define how this template's going to accept inputs once we deploy it and use it. You've got variables, resources. There's a few different sections of templates. Again, this exam, you don't need to know those, so we're not going to go into them. Just know that, again, what ARM templates do from a high-level overview and that they are extremely helpful. Okay. Azure Policy. Huge service you're definitely going to want to know about. Basically, when you are asked about how to maintain like compliance to corporate policy, whatever, start thinking about Azure Policy. Okay, Azure Policy helps to enforce organizational standards and to assess compliance at scale. All right, your compliance can relate to security, resource consistency, regulatory compliance, cost management, or any sort of let's call it a component of maybe an SLA that you have, just anything, right? It's very flexible, but it just helps keep things up to a specific standard, all right? Microsoft Purview is a service that lets you get visibility into all your data and manage your assets across your environment, right? It secures your data throughout its entire life cycle across different applications, clouds, and devices, and it identifies data risks and helps you manage regulatory requirements. Okay. Whoa. Azure Arc is a service designed as a bridge to extend Azure's platform, I should say, to help you build applications and services with the flexibility to run across data centers at the edge and in multi-cloud environments. So, basically, if you are at a company which uses a few different cloud providers, maybe some on-prem as well, which is actually very common, then Arc is going to allow you to sort of centralize how you're managing and running these different environments across these different providers or hybrid sort of setups. All right, so containers. Let's actually take like a quick, I don't know, 3, 4, 5, whatever minute break. We'll come back here, and then we may actually be able to sprint to the end. Let's see, 81. We'll see. We'll figure it out. But for now, let's go ahead and take a break. When we come back, we'll pick it up with containers, and we'll go from there. All right. So we'll see you here in a few minutes. All right. All right, let's get back into it. Maybe we can get a nice little push to the end here. We'll see what we can do. All right, so containers. This is a pretty brief section. You don't really have to know in depth about containers. You just kind of got to know what they are, which we talked briefly earlier about them, but we'll do it again just to really hammer it home. All right. So containers allow you to bundle up everything an application needs to run except for the actual operating system. Azure Container Apps and Kubernetes are pretty much all you'll need to know for this particular exam. Okay, so don't get too carried away unless you just really want to dive down into a container rabbit hole, which that's a large rabbit hole. So containers visualized. So basically you have your Azure environment. You could have a couple different container apps. Excuse me, you've got a few different revisions, so like some versions. You've got some containers in here. You've got some replicas. But these containers can kind of be like just sort of picked up and then moved to maybe another environment, maybe another revision. They're very flexible, okay, and that's the whole point. They're very flexible. They are designed to, basically need everything that an application needs to run except for the operating system. Okay, container has it all. All right. So Azure Container Apps build and deploy fully managed cloud native apps and microservices using serverless containers. It's based on Kubernetes, but allows you to not have to do that container management yourself. Kubernetes is definitely not the most user-friendly or easiest thing to do, so to abstract that all out is definitely helpful. But if you do need to do that orchestration yourself, there's Azure Kubernetes Service, right, which is a unified management and governance for on-prem, edge, and multi-cloud Kubernetes clusters. Similar container apps, except that again, it's going to be more work because you're going to have more control over your container orchestration. Okay? Boom, that's it. Containers done. Monitoring tools, a little more relevant because we want to know what is going on. You need to always be monitoring your resources and applications so you can be proactive. If you're not monitoring, it really is a problem. Okay, you're just waiting for something to happen, and then when it does happen, you're gonna have no idea why, no idea how to fix it, and no idea how to improve in the future. You can monitor and/or log events from resources, applications, and even your different Azure accounts. Okay, it's very in-depth, very granular. The main services you'll encounter for monitoring purposes are Azure Monitor, Advisor, Service Health, Log Analytics, and Application Insights. Okay, so Azure Monitor is a comprehensive monitoring solution for collecting, analyzing, and responding to monitoring data from your cloud and on-prem environments. Okay. So in this picture here, we've got, a few different data sources, right? Apps and workloads, infrastructure, Azure platform, maybe again on-prem. Azure Monitor is going to keep up with some metrics, logs, traces, changes in the domain of all these different sort of services and some. You also, of course, can, again, monitor a few different other services, like, maybe some of your databases, maybe your Power BI dashboards, and then you could take this data from Monitor and integrate it with maybe event hubs to trigger things to happen. Storage, maybe you could have lifecycle rules. There's all sorts of different ways you can integrate your log findings and data into other tools, applications, services, whatever. Okay. Azure Advisor is a personalized cloud consultant that helps you follow best practices to optimize your Azure deployments. It's a dashboard that gives you recommendations in the following domains, right? It might look familiar, that well-architected framework. So reliability, security, performance, cost optimization, and operational excellence, all right? Just kind of covers you across the board. Azure Service Health notifies you about Azure service incidences and planned maintenance so you can take action to mitigate that downtime so it has little to no impact on your apps and your stack, your infrastructure. It's helpful to keep you informed of maybe if there are outages or updates, and your application has resources that depend on those services or Azure resources being affected. So you can either, notify end users, hey, we're going to have 30 minutes of downtime, or you can maybe like fail over to a different set of VMs, whatever it is. You just want to know if Azure has something going on, even though it's definitely unlikely and not common. It does happen, so it's nice to be aware. Okay? Log analytics are designed to work with the logs that you collected via monitor that we looked at earlier, and it lets you run specific queries against that log data. All right. And you can use log analytics for simple queries to see when and or why something happened, or maybe some more complex queries for statistical analysis that you can then integrate into a dashboard, maybe Power BI, maybe something else. It's up to you. Yeah. And then application insights are designed as an application performance management tool for live web applications. All right. It allows you to enhance the performance, reliability, and quality of your applications. And if you just want a visual of how it actually works and is handled, here you go. We don't need to dive too much into it because you're not going to be asked, you know, this sort of depth. All right, but again, good to know, not necessary to know everything. All right, just understand from a high level what we're doing with App Insights, and that is monitoring live web apps. All right. All right, cost management and billing. I promised we'd talk about this a little bit more, and here it is. So, the primary selling point of Azure and just the cloud in general is that you can work off of a consumption-based model, which basically means you're only going to pay for resources you use and or consume. The cloud's going to give you greater flexibility over your expenses. So think, again, operating and capital resources so that you can make sure your organization's cash is being distributed most efficiently. Okay, there's only a finite amount. I don't care what company you work at. You got to use it as efficiently as you can. All right. You want to use visual friendly tools when communicating costs, especially with non technical folks, as most people that actually handle and distribute the money, they don't have uh, the knowledge to deal with resources and infrastructure, and quite frankly, they don't care. They just want to hear about the value and where the money's going. Okay. So, it's important to understand this concept of TCO, right? The total cost of ownership. Basically, it is going to allow you to compare the cost of owning and maintaining your own on prem physical servers and data centers and hire people that basically, do all those things and some. Okay. Uh, or on the other hand, if you use Azure service servers and adopt a pay-as-you-go model, right, you could potentially save a lot of money as opposed to option A up here, okay? Because option A, if you're doing your own stuff, you got to consider the hardware and software costs. Does your software work as you need it to? Does it scale if you get more or less demand? How long does it take to implement it or to make new changes, updates, whatever? There's all sorts of things you got to consider. You can get rid of all those if you just offload it to Azure potentially, right? So it's important to know TCO, and there's definitely a TCO calculator that you can use with Azure. Right? All right. So how do you pay for Azure resources? Well, when you sign up to use Azure, you have to create a billing account and a subscription, at least one subscription. A billing account is sort of a centralized account to manage invoices, payments, and track costs. Okay? And then, like we looked at earlier, a subscription contains resources and or resource groups, and you can have multiple subscriptions per billing account. Larger organizations can have more complexity than this by using multi-tenant billing relationships, but again, that's out of scope for this particular exam. Okay? So that's basically it, right? You sign up, you give them a credit card, you have a billing account, create a subscription, you're off to the races. Okay? Pretty simple, pretty user-friendly. Uh, but it's important to know what actually affects your costs, right? So, regardless of if you're using Azure or another cloud provider, the actions and or resources that actually accrue charges, they're pretty similar, okay? So if you're consuming compute power or using, different sized VMs, that's going to cause your price, your bill to be more or less, okay? How much storage and or database capacity you consume and or provision is going to impact it. Are you transferring data either out of the cloud or between different regions? That's going to cost you money. And like I mentioned earlier, some regions are more expensive to operate in. Some services are more expensive in particular regions. There's all sorts of variables. Okay? So it's nice to, again, monitor and sort of keep up with and proactively, continuously update your resources so that you're staying in line with your budgets and getting the highest return on investment ROI that you can possibly get. Okay. So the pricing calculator is a free tool that can be used to estimate the cost of various Azure services. It contains over 100 services that you can use in your estimate. And it could also be used to help you sort of establish that TCO, right? Compare and contrast on-prem versus in Azure, so that you can, again, make sure that you're spending money as efficiently as possible. Maybe you only have some of your workloads go to the cloud instead of all of it, right? It doesn't have to be all or nothing. You could maybe store your data, store your backups in the cloud, and have your apps running on-prem. It's really up to you. All right, Azure budgets. So you can set up budgets that will send you alerts if you are either approaching, at, or exceeding your defined budget. Okay? It's important to remember that if you exceed a budget, it's not going to stop your resources from running. Okay? It's just going to send you a notification saying, hey, you better do something. I've done my job. You can share budgets with others who are not involved with Azure. Again, other than paying for it, maybe they just want to be notified if they're about to be spending a lot more money than expected. Okay. Cost analysis dashboard. So this is, as you can see, a very user-friendly visual. It helps you visualize, understand, and manage your Azure costs and usage over time. You can use smart views to show recommended and or important insights, or even customizable views to show you basically whatever you want if you need to present specific costs. Okay. Tagging. So tags are metadata that can be applied to pretty much any resource to help you better identify and group them. It works based off of key value pairs. So, for example, you could have multiple departments, maybe one for sales, one for dev, multiple environments, one for prod, one for test. Tagging, you can basically have them be whatever you want, but just try to make them efficient, try to make them practical. Don't use too many, just use what you need and make sure you use them consistently and often. Okay? Cost allocation rules. So these allow you to distribute or redistribute where the costs of your shared services go. So in a large organization, maybe you've got a certain department that's only using, like these specific resources. They're the only ones, so you want them to be paying for it instead of the rest of the organization divvying up the cost for that. You can do that, but only if you have an enterprise agreement or a Microsoft customer agreement in place. Okay, those are kind of the two caveats there. So it's up to you on if you want to go down that route or not, but you're probably only going to if you're at a larger company, all right? All right. So service definitions. Let's just go ahead and fly through these. Be another 15 minutes, and then we'll be done here. We're gonna finish this in about 2.5 hours, something like that. So yeah, pretty quick, guys. I mean, again, this isn't a super challenging test. You definitely want to be prepared, but you can definitely do it. All right. So these definitions coming up here are going to be a non-exhaustive list of services that are considered fair game on your test. So it's not going to encompass everything, but it'll encompass definitely everything you need to know, like all the major services, some of the minor services, but there might be some like one-off things you see on the test, but it's not going to be it's not going to be likely, okay? More than likely this is going to cover everything, all right? So if you're watching this video and maybe you're looking for like last minute test prep, this is perhaps the section you want to skip to, but really try to use active recall, right? Don't just come in here and read everything. Look at a service before you read what the definition is. Try to tell yourself and remember what it actually is and does. So, that'll help you cement it in your mind better because, of course, when you actually go to take the test, that's all you got is active recall. You can't look at a definition, okay? You got to just figure it out. Again, these services, just conceptually know what they are, what they do. You don't have to deep dive into really anything for this particular exam. The only details you really need are what we already covered previously. Okay, so if you're feeling fuzzy on something, go back, review it in this section, or in this study guide rather, and if it is something that's not covered before this sort of service definition section, then you don't need to know too much about it. Just know like maybe the definition of it and what it does. Okay. All right. Let me get some water and then we'll rapid fire. Okay, let's do this. So, technologies and concepts, just sort of general things. All right. APIs, application programming interface, helps programs talk to each other. Cost analysis provides detailed insights into organizational spending patterns and cost trends to identify areas for potential savings. Budgets allow you to set up budgetary constraints on Azure services to control spending and proactively manage costs. The Azure portal is a web interface to manage your Azure resources. Azure Resource Manager provides a management layer that then enables you to create, update, and delete resources in your Azure account. Azure CLI is the command line interface that programmatically manages your Azure resources. Azure Cost Management and Billing provides tools to monitor, allocate, and optimize cloud costs with transparency and accuracy. The total cost of ownership, TCO, is what assists in estimating the cost savings of being in Azure in the cloud compared to doing things yourself on-prem. Okay? Single sign-on, SSO, is where you log into multiple apps with a single set of credentials. Okay? MFA, multi-factor authentication, is where you authenticate a login with a password in conjunction with a text or an email or just some other way of confirming that you are who you say you are. Okay. Elastic load balancers distribute traffic between resources, VM types. You got reserved, on demand, or spot. Security groups can be, they are stateful, right? Meaning that they control traffic at the instance at the VM level. Network access control lists, NACLs, are stateless. They control traffic at the network, the subnet level. Right? Azure Service Health gains insight into the health of Azure services that could potentially affect your resources if they're having problems. VPN, Virtual Private Network, is a secure connection between end users and your network. Infrastructure as a Service, IaaS, is a type of cloud computing service that offers essential compute, storage, and networking resources on demand on a pay-as-you-go basis. Platform as a Service, PaaS, is a complete development and deployment environment in the cloud with resources that enable you to deliver cloud-based apps. Okay, so bring your own code. Software as a Service allows users to connect to and use cloud-based apps over the internet. So here's the finished product. Pay me and you can use it. All right, so now we're going to get into some actual Azure services and features. All right, so if we look at compute services, we've got VMs. Virtual machines provide scalable, on-demand computing resources for running applications and workloads in the cloud. Azure App Service, or Services rather, a platform for building, deploying, and scaling web apps and APIs with support for multiple languages and frameworks. Azure Functions enable the creation of event-driven serverless compute solutions that can scale with demand. Azure Storage Service, different tier here obviously than compute, but you've got blob storage, which offers scalable and secure cloud storage for large amounts of unstructured data like images, videos, and logs. Azure File Storage provides managed file shares in the cloud, accessible via the industry standard SMB and NFS protocol. Azure Queue Storage is a service for storing large numbers of messages that can be accessed from just about anywhere in the world. And then interesting. So you've also got table storage, which is that NoSQL data storage. And then you've also got disk storage that is going to be used for sort of locally storage. There's local to your VM, so high throughput, but it can be more expensive. Okay? Azure Database services. So you've got Azure SQL Database, which is a fully managed relational database service based on SQL Server. Cosmos DB is a globally distributed multi-model database service for any scale that primarily is used for NoSQL databases. Okay. Azure Networking Services. You've got VNets, virtual networks that provide an isolated private environment in the cloud for securely running VMs and other applications. Azure Load Balancer offers high availability and network performance to your applications by distributing traffic. Azure Container Services. You've got container apps, which build and deploy fully managed cloud native apps and microservices using serverless containers. Kubernetes service. Gives you unified management and governance for on-premise edge and multi-cloud Kubernetes clusters. Okay, you get to orchestrate clusters and control it all. Identity service, you've got Entra ID, formerly Azure Active Directory, AD. It's a comprehensive identity and access management cloud solution which provides a set of capabilities to manage users and groups. Role-based access control, aka RBAC, lets you manage who has access to Azure resources, what they can do with them, and what areas they can actually access. Okay? Azure Management Tools, you've got the Azure Portal, which is a web-based unified console that provides an alternative to command line tools for managing Azure resources. Azure PowerShell and CLI are command line tools for managing Azure resources. And Azure Resource Manager provides a management layer that enables you to create, update, and delete resources in your Azure account. IoT services. IoT Hub is a central hub for bidirectional communication between IoT, so the Internet of Things, applications, and the devices it manages. Azure AI, artificial intelligence, and machine learning, ML services. You've got ML service, which is a cloud service for accelerating and managing the ML project lifecycle. Security service, you've got Security Center, which provides a unified security management and advanced threat protection across hybrid cloud workloads. You've got Key Vault, which is a tool for securely storing and accessing secrets such as API keys and passwords in the cloud. Okay? Azure Integration Services. Azure Logic Apps is a cloud service that helps you schedule, automate, and orchestrate tasks, business processes, and workflows. All right, here we go. Hard part's over. Okay, at this point, maybe after a couple weeks of doing this, if you're not ready to take your test yet, review for another week or so. But, I would say you should be ready to take this test. And, if you've got some experience in IT and tech and cloud, a couple weeks, you should be good. If you have no experience starting from scratch, give yourself maybe 4, 5, 6 weeks, okay? But regardless, when you're ready to take the test, again, rule out 1 to 2 answers. We already kind of talked about that. Know that every service that they offer you is a real answer, okay? It's more important to know the context, and like I kind of said a few hours ago, what's the best answer? How is the best, what's the best case scenario, the most logical option to use this particular service in, okay? This is an intro level test, so don't dive too deep unless something actually interests you, and in that case, go for it. I think that's great. If you can, know the abbreviations of services and different, offerings, like the redundancy options, for example, know those abbreviations for sure, like the LRS, GRS, whatever, RA, GRS, all those good things. Don't flag too many questions for review. This is a quick test. Really just try to get after it and just flag down a handful to review at the end. And like I said, man, just the day before you test, chill out. Don't go crazy. Watch a movie, whatever hobbies you're into, just do that. You might want to worst case scenario, just review like a practice quiz maybe. But even that, I wouldn't even recommend doing that. Just hang out and chill. Maybe look at some things that interest you. But yeah, don't do too much related to this because you want to go in feeling relaxed, ready to go, and confident. Okay? All right, so to schedule your test, you can do it either at a testing center or at home. I'd recommend doing it at a testing center. It's kind of weird doing it at home. They make you set up a camera at a certain angle, and there's just all sorts of rules, right? You show up to a testing center, you just sit down, take your test, boom, that's it. All right, and you don't really have any distractions. You can consider attending a Microsoft Virtual Training Day, as they tend to give out exam vouchers to take tests for free, whether this one or other Azure exams. And of course, you'll learn a few things at a training day, I would hope. And then when you're ready to schedule your test, you could just go here to this link. But Microsoft likes to change things, so if this doesn't work at some point in the future, just Google, AZ-900 test, schedule, whatever. You'll find it. Do some Googling. All right. All right. Well, we made it to the end. I hope this is helpful. Again, feel free to check out our full study guides and the links in the description, as well as our practice tests I'll put one of those up on the channel as well, but if you want all of them, check them out on our site as well. Again, you can find all those links in the description. But, thanks, guys and girls, ladies, gentlemen, whoever you are, for tuning in. Best of luck to you. Remember, you can easily get this test on your first try. It's an intro level exam, but regardless, I wish you the best. Thanks for hanging out with me for a few hours, and we will see you in the next one.